So we went over what software architecture is, and we went over this acronym to help us remember several different types of software architectures. So now we're going to take this first one in our DLC coder acronym, Dataflow, and kind of explain it on a more in-depth level. So, as I mentioned before, this specific architecture is called Dataflow. And this is called Dataflow because the data, I suppose, to lack of a better word, flows through the architecture in a way that's very similar to Unix's pipe and filter model. So what it does, it takes the data from previous functions and uses that output as input for later functions. And just to, I guess, demonstrate this, let's imagine that we have an invoice system. And this invoice system, I'll go ahead and label that here. So we have an invoice system. And the goal of this invoice system is to first, obviously, generate an invoice, then see if a particular user has paid, and if they have paid, issue them a receipt, and if they haven't paid and it's due, issue them a reminder that they need to pay off their dues. So first, we're going to go ahead and just draw our function here, and we'll just pretend this is the invoice function where we generate our invoices. So we'll call that invoices. Then we'll draw an arrow. And we'll go ahead and call this one as you read the invoices. So this is pretty much just storing the data of the invoices. So it takes all this invoice data, and then it's going to use that as an input for our payment function. And this payment function is more of a, I suppose, check payment. So it's going to check the invoice to see if it has been paid or not. It's going to use that information. So we'll say that at this point in our architecture, the payment has been identified. So we've taken this invoice data, we've used it as an input for our payment function, and we've been able to say, okay, well, we have two possibilities right now. So we have possibility A, and we have possibility B. Now, possibility A means we have a fulfilled invoice. We have a fulfilled payment. So we want to issue a receipt for that payment. So the user can go ahead and say, okay, I paid that off, and the system's just confirming it. So that's going to go through just, let's call this a receipt function that will go ahead and send a receipt to the user. Alternatively, we can say that instead the payment is due, so they have not paid yet. So we want to say send payment due. So we're going to send them a reminder just saying, hey, your payment is due. So we'll call this a remind function, which we're just going to remind the customer they have an overdue payment. So in a nutshell, that's this data overflow model for like an invoice system. We generate our invoice, and then from that invoice, we can then validate a payment. So if the payment doesn't completely fulfill what's on the invoice, then, well, we have to send them a payment reminder like, hey, your payment is past due. Please pay back the company what you owe them. So we go to the reminder function and send it to the user. So or alternatively, we say, okay, well, they've paid off the entire invoice, so we issue a receipt to the customer. And the customer receives that receipt just to make sure, for sure they have paid off that due. And this is the first example of several different software architectures we'll go over. The next one will tackle the layered system, which is very useful for web applications. In fact, I'll probably end up using the web application to explain it. And then after that, we'll go on to client server, then centralized control, object-oriented, domain-specific, event-driven, and repository. And then after that, we would have covered all of our different software architectures, and we'll move on to the next part of the design of our software.